A cosmic question: why imagine worlds colliding? The universe is vast and dynamic, things move and collide. Thinking about a collision like our moon hitting Mars helps us understand cosmic forces. How could our moon ever leave Earth's embrace and head for Mars? This is the first hurdle in our thought experiment. The moon is held tightly by Earth's gravity. It would take an immense amount of energy to send it careening off into space. Perhaps a rogue planet, a massive asteroid, or even an artificial event could provide the necessary gravitational nudge. This external force would need to be precisely aimed. It would have to alter the moon's velocity just enough to break free from Earth's orbit. It would then begin a new trajectory, one that intersects with Mars. Let's imagine such a trigger event occurs. The moon slowly drifts away from Earth. At first, the changes on Earth might be subtle, but as it moves further, its gravitational influence would wane. The journey to Mars would not be swift. Space is vast. Even at high speeds, it would take months, perhaps years, for the moon to reach the red planet. During this journey, it would be a rogue celestial body. Its path would be governed by the sun's gravity and the pull of other planets. Scientists on Earth would watch in horror and fascination. They would calculate its trajectory, predicting the inevitable. The moon, now an independent wanderer, would face its own perils. It could be captured by Jupiter's immense gravity. Back on Earth, the moon's departure spells immediate trouble. The most obvious effect is on our tides. The moon's gravity is the primary driver of ocean tides. The sun also contributes, but the moon's proximity gives it a stronger influence. Without the moon, the familiar rhythm of high and low tides would vanish. Ocean waters, no longer pulled by the moon, would redistribute. The sun's gravity would still cause tides, but they would be much weaker. These solar tides would be about 1/3 the strength of the lunar tides we are used to. This sudden change in tidal forces would be chaotic. Coastal ecosystems, which are finely tuned to the twice-daily ebb and flow of water, would be devastated. Intertidal zones, rich in biodiversity, would either be permanently submerged or left high and dry. This would cause mass die-offs of marine life. Coastal cities and infrastructure, built with current sea levels and tidal ranges in mind, would face unprecedented challenges. Some areas might experience permanent flooding, others might see their harbors become unusable. The very shape of our coastlines could begin to change. The loss of strong lunar tides would also affect ocean currents. Tides play a role in mixing ocean waters. The moon does more than just create tides. It acts like a gyroscope for Earth. Our planet spins on an axis. This axis is tilted at about 23.5 degrees relative to our orbit around the sun. This tilt is what gives us seasons. The moon's gravity helps to stabilize this tilt. Without the moon, Earth's axial tilt, also known as its obliquity, would become much more unstable. It would begin to wobble erratically over long periods. This wobble would be far more pronounced than the gentle precession we currently experience. Imagine Earth's tilt changing wildly. It could swing from nearly 0 degrees, meaning no seasons, to extreme angles. If the tilt became very large, say 60 or 80 degrees, the consequences for climate would be catastrophic. Polar regions could receive direct sunlight for extended periods. Equatorial regions might experience long, dark winters. Such drastic shifts would make it incredibly difficult for complex life to survive. The stable climate we have enjoyed, which allowed civilization to flourish, would be a thing of the past. Our seasons would become unpredictable and extreme. These changes in axial tilt wouldn't happen overnight. Section 5. The ground beneath our feet. Earth's crust reacts. The moon's gravitational influence extends beyond tides and axial tilt. As mentioned, it causes solid Earth tides. The removal of this constant flexing, however subtle, could have geological consequences. The Earth's crust is made of tectonic plates. These plates are constantly moving, driven by currents in the mantle below. This movement causes earthquakes and volcanic activity, especially at plate boundaries. The stresses within the crust are complex. The moon's gravity is one of the many forces contributing to this stress balance. Losing the moon would alter this balance. The sudden removal of its gravitational pull and the associated land tides could potentially trigger an increase in geological activity. Fault lines that are already under stress might be pushed to their breaking point. This could lead to more frequent or more powerful earthquakes in certain regions. Volcanic activity might also see an uptick. Magma chambers beneath the surface are sensitive to changes in pressure. A shift in crustal stresses could influence eruptions. The planet might literally groan under the strain of this celestial loss. While a sudden global cataclysm of earthquakes and volcanoes is unlikely, the changes would be significant over time. Section 6. Impact. Mars meets Moon. A cataclysm of epic proportions. Now let's turn our attention to Mars. The Moon, our former companion, finally reaches its destination. The impact would be an event of unimaginable violence. The Moon, with a diameter of about 3,474 kilometers, is not a small object. Mars has a diameter of about 6,779 kilometers. This is a collision between two substantial celestial bodies. As the Moon accelerates in Mars's gravitational well, it would strike the Martian surface at incredible speed, likely tens of thousands of kilometers per hour. The energy released would be colossal, dwarfing all nuclear arsenals on Earth combined. The moment of impact would create a crater of immense size, hundreds, perhaps thousands of kilometers across. A vast plume of vaporized rock and debris from both the Moon and Mars would be ejected. Some of this material would be blasted into space, some would fall back onto the Martian surface, blanketing the planet in a thick layer of hot dust and rock. The shockwave from the impact would travel through the planet, triggering global Marsquakes of incredible magnitude. Mars's relatively thin crust would be shattered and reformed in the impact zone. The immediate aftermath would be a Martian hellscape. The energy released would melt vast swaths of the Martian surface. Section 7. Mars transformed. A new surface, a changed atmosphere. The long-term consequences for Mars would be profound. After the initial chaos of the impact subsides, a new Mars would emerge. The massive impact crater would be the most prominent new feature. The ejecta blanket, the material thrown out from the crater, would cover a significant portion of the planet. This material would be a mixture of lunar rock and Martian rock, creating a new type of surface geology. Future geologists, if any ever reached Mars, would have a fascinating, albeit terrifying, new world to study. The impact would likely add significant mass to Mars. The Moon is not insignificant. This added mass could subtly alter Mars's orbit around the Sun. It could also affect its rotation period and axial tilt. Over geological timescales, these changes could lead to different climate patterns on Mars than it would have otherwise experienced. The impact might also re-liquefy parts of Mars's core, potentially reigniting a magnetic field for a period. A magnetic field could offer some protection from solar radiation, which Mars currently lacks. This could be a temporary, unexpected side effect. Mars's thin atmosphere would be drastically changed. The immense energy of the impact would vaporize rock and any ice deposits near the impact site. This would release huge amounts of gas and water vapor into the atmosphere. Section 8. Red Planet Dreams Dashed. The end of Martian colonization, the end of Martian colonization. A celestial catastrophe would devastate our Mars ambitions. For decades, scientists and engineers have dreamed of sending humans to Mars. We envisioned permanent settlements and terraforming Mars. The Moon crashing into Mars would end these dreams violently. Mars would become unsuitable for colonization for millions of years. Existing missions like Curiosity or Perseverance would be destroyed. The data they collected would be lost. Decades of scientific investment would be wiped out. Future human missions would be indefinitely postponed or cancelled. Mars would be hazardous and unstable. The atmosphere would be choked with dust and seismically active. Resources like water ice might be vaporized or buried. The thin atmosphere would become even more hostile. Terraforming Mars would become an impossible fantasy. The planet would be too geologically unstable. Fixing Mars would be beyond human capability. Section 9. Two worlds altered. The lasting scars of a celestial crash. A hypothetical Moon-Mars collision would change both planets forever. Earth would face tidal disruption and climate instability. Mars would become geologically hyperactive. This scenario highlights the delicate balance of our solar system. The Moon's influence on Earth is profound and essential. Such cosmic events remind us of the solar system's violent history.